recording. For this assignment, as I said, you have to perform binary search many times using multiple threads in order to solve a puzzle. The puzzle can be very large, up to 2 billion character long, and it's nothing but a sequence of randomly generated characters that can be generated using a program similar to randomgen.c, which is given canvas. And I have given a starter code that has implemented this solution, but you have to make the proper changes or appropriate changes to the program so that the program can be handled or can be managed by these command and arguments and options. One of the arguments specifies the length of meaningful words that we are interested in. Solving a puzzle basically means finding meaningful words inside that sequence of whatever number of characters we have, like 5 million or 2 billion characters we have. We want to find meaningful words. The -len command argument basically allows the user to specify how long a meaningful words should be as the solution of your puzzle. So if you say -len 5, that means find all the meaningful words with length 5 in this random sequence of characters, right? And if you give like a different number, the program should find a different length of meaningful words. And you can also pass multiple length. You can say 8,9 or 5,6, 7, 8. You can just pass like different no, more than one length, and the program has to find all the meaningful words with all of those given length. But you got to remember they should be separated by comma. So if you're going to say 5 and 6, you say -len space 5, 6. Don't put a space between, only comma. Right? So -len space 5, 6 means give me all the meaningful words with length 5 or 6. The default value is 8 and 9, which means by default, if there is no -len flag, your program has to satisfy the following condition. It should find all the meaningful words whose length are 8 and all the meaningful words whose length are 9. So it should behave by default this way. And then -n threads n would be another flag and another command and argument. That means how many threads do you want to solve the puzzle. The default value is 1. When I say for -len I have a default value, or for -n threads I have default value, it means that these command and arguments may not even exist. If they don't exist, we go with the default value. The default for len is 8 and 9. For number of threads is 1. But you can have like any value. You can have like 10, 20, 30. Don't go beyond 90. 90 is too many. Don't try to break the ocelot. That's not a good idea. Then verbose would be another flag. This basically allows this -verbose tells the program to announce multiple things. First, whenever you create a thread, announce that. Say this thread is created. Whenever that thread is joined, announce that. Whenever you print the total runtime, whenever you finish the whole operation, print the total runtime in second. That means at the very end, say how long did it take this program to run and find the solutions for the puzzle. And then dash time would be another flag, which basically calculates and prints out the total time spent on binary search only. That's different from the variables. You need to print the total time that your program spent on this function, which I'll talk about this function. This function basically is the main procedure to solve the puzzle. When you're solving a puzzle, you're basically trying to search for a meaningful word in a very long dictionary list of words. The list of words are given in the assignment. So if you click on this, you will get the list of all 93,512 English words that are basically placed in alphabetical order. So you need to read this file, store it in an array of size 93,512 or longer. And then what you need to do is you need to do a binary search to find out whether or not a given string is meaningful. If the given string is part of the is one of the values that are in the dictionary.txt, then it is meaningful. Otherwise, it's not meaningful. That's how you find out whether a puzzle word is valid, or whether a word is the answer to the puzzle, legal answer to the puzzle. And the time is going to calculate the total binary search times. And you need to store a long integer in your program if you want to calculate the total binary search time. And because this variable is going to be a shared variable, you got to be careful not to corrupt this, because you have many threads doing binary search, and after they finish their binary search, they're going to increase this total binary search time variable. So it may be prone to the race condition problem. If you remember, when you have a shared variable, like in the example of bank account, balance was a shared variable. When the balance is being manipulated by multiple threads, either withdraw or the deposit threads, that gets corrupted. We saw that in the previous lectures and videos. So that means what? That means you gotta protect the total binary search time with a mutex lock and unlock. So before making any changes to this variable, threads should lock a single mutex, and after finishing their operation, after updating the total binary search time, they should unlock it. This is in a snake case. This should be in the snake case. This is not correct way. It should be total underline binary underline search underline, but you can fix that yourself. Then you have dash sorted flag, which is telling the program that you must sort the list of found words before printing them out. And in order to do that, you need to tell the threads whenever they find a solution, they should store it in an array of words. They should not print it immediately. And after that array of words is populated with all the answers to the puzzle, then you need to sort that puzzle. And I have already posted a video, code for sorting an array of strings, right? For a C in a C program. So you already know how to sort a list of words. And then finally, dash distinct will eliminate the duplicate values from the output. So if you have a dash distinct in the program, that means after the program finds all the meaningful words and wants to print out the the solution for the puzzle, it has to avoid printing duplicate solutions. So let's say the word apple has appeared in the long random string twice. You only need to print it once if it's part of the puzzle solution, right? So you should not print duplicate meaningful words on the console as the solution to the puzzle. And here are the submission criteria, and then don't forget, the 10 points for makefile is important. You should write the proper makefile with the executable name set to word puzzle. And if you don't do that, you're going to lose that 10 points. And then you can see how to get the other 90 points, 15 points for every command argument, basically. In order to get the full credit, you need to do these 6 different flags. And also you need to do the makefile. If you do want to get an extra credit, you can get a 10% extra credit by creating a JPEG file, plotting the total runtime of the program over the number of threads when the number of threads varies between 1 to 90 in this form. So you need to draw a plot. The x-axis would be basically how many threads you have, and the y-axis would be the exact time. And then you need to use a regression line to show the trend of running time over different threads, which is going to be a very interesting plot to see. You're going to get another 10%, so you can get up to 110%. With that, let's get into the starter code, and then after that I'm going to show you how to run the starter code. So this is the starter code. You have a buffer made of 20 threads because, in the starter code I decided to go with 20, but that's not going to be the case in your final program. You should allow any number of threads, depends on how the user decides in the command argument. And then I have the binary search, as you see. This is the same code that I showed you in the PDF file. Then I have an array of char stars made of 100,000 elements. I only need 93,512 of them because my dictionary length is that many. Then I have a function which is super useful. It's going to get the time, the current time, in nanoseconds. So whenever you want to know what the time is, you're going to call this function. Why do you need this, the current time? Because you want to measure the time intervals. So if I call this function at the very beginning, and if I call it at the very end, and I subtract the two numbers, the total the difference is going to give me the total running time of the program. So remember that. Don't change this program, this function. Don't change this function. These are, but they must be there. And then I have a start routine for the puzzle solver threads. As I said, you have like 20 threads in this program. So you need to have like 20 threads. Each of them will have the same start routine. And the start routine, as you see, is very simple. It basically prints on the standard error stream that thread with this ID number has a start, right? And after that, you have a for loop that allows the puzzle solving process to happen gradually. Basically, n is going to be the number of times that we are going to do a binary search, and that's going to be set equal to the buffer size, which is set to 2 billion because I made this for when you're solving a 2 billion byte puzzle, that's the maximum possible value divided by the number of threads minus length. And the reason I'm dividing the buffer size by the number of threads is because I assume that each thread has to have an equal length of puzzle. So let me give you an example. Let's say, I don't want to consider 2 billion, 2 billion is too much, but let's say you have a puzzle of size 100. That means you have a like sequence of 100 random characters. And then you have, let's say, 5 different threads. So you break this into 5 equal pieces. So let's say this is your puzzle. This one has 20 characters in it. 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 And this one has 20 characters in it. Basically, what I will do is I'm going to go over the one puzzle or one piece of this puzzle. I'm sorry. In each thread, I'm going to go over only 1/5 of this sequence, and I try to look for the solution for the puzzle in each piece. So if you have 5 threads, thread T1 solves this part of the puzzle, thread T2 solves this part of the puzzle, thread T3 solves this part of the puzzle, thread T4 solves this part of the puzzle, and thread T5 solves this part of the puzzle. And because each thread is responsible for one part, they're collectively will solve the whole puzzle, right? So that's how you break down the problem into equal size pieces so that each thread can have the same load of work, right? So that the reason we divide the puzzle size by the number of threads is because we want each thread to get equal share of the puzzle. And the reason we do minus len is because we don't want to go out of bounds. So let's clear all of that. In a for loop, we are gonna check this C, which is gonna be a character set to 0. That basically says, are you in the first iteration or not? If you're not in the first iteration, then you're gonna do this. Otherwise, if you're in the first iteration, you start this way. You're gonna store buff of I plus len into C, and then you set buff of I plus len into equal to 0. Then you will do the binary search to look for, to see if the string is stored at buff plus I is a meaningful word or not. If it is meaningful, then the binary search does not return -1. And if it doesn't return -1, then this would be true. And it's going to print the string is stored at buff plus I. Let me explain this a little bit more because it's kind of hard to understand, but it works. But if you want to understand why it works, let me show you how. Let me show you why. Let's say your input string looks like this. I have A, B, C, D, E, F, A, P, P, L, E, X, Y, Z. Let's say this is my input. At some point, I start I from 0, and I let's say this is my buff. And let's say, in order to simplify that, let's say len is equal to 5. So len is equal to 5. That means I'm looking for a 5-letter word. I start I from 0. And what I will do basically is I set buff of I plus len equal to 0. So basically I say 0, 1, 2, 3, 4, 5. I'm going to set this to 0. So this becomes 0. Before doing that, I'm going to store it in C so I don't lose the letter F. I store F into a temporary character, which is considered to be C. So C is equal to letter F. And I set this to 0. And when I set this to 0, then this part of my puzzle would be a single string. Because if you remember, the strings in C ends with a 0. Then I will call the binary search on this word, this 5-letter word, and see if this is going to be one of the elements in the dictionary. What is dictionary? This is already filled up by the sequence of words in the dictionary.txt, which I'll show you in the main. The main is going to do its job properly. So if the binary search finds it, if it doesn't find it, then it's going to return -1. And if this is -1, if the search is not successful, it returns -1. -1 plus 1 would be 0, and 0 means false. We are not going to print the output. We are not going to print the solution. And, that means we're going to go forward and we're going to try a different I. Then we're going to check I plus 1. And if it was successful, then we would print out buff plus I. For example, we would print out A plus A, B, C, D. But it's not part of the dictionary, so we would go forward. At some point, I becomes this value, which is equal to 6. And that's the beginning of the apple, right? And this line again kicks in and sets, and I'm sorry, this line kicks in and sets buff of I plus len to 0. That means it's going to replace X with 0. And then it's going to say, let's do a binary search for this part of the string, which is the word apple, and see if this is in the dictionary. Obviously, this is going to be in the dictionary, so this is not going to be -1. This is going to be a non-zero, non-1 value. Like it's going to be a positive value. And that value plus 1 would still be positive. It's not going to be 0. So we are going to print out that this thread has found the word apple. And then that's how this, for loop works. Basically, goes over the whole sub puzzle that this thread is responsible for solving it and tries to find all the meaningful words. Now, if you want to choose a different length, for example, let's say right now the len is equal to 9, right? But the default should be 8 and 9. So all you need to do is to place this inside an outer for loop. And in the outer for loop, you need to update the len and set the len equal to different values that the user wants. For example, if it's 8 and 9, you can place this into another loop and say for int len from 8, len less than or equal to 9, len plus plus, and then instead of the capital len, you will say lower len. And then so capital len, you would say lower len. So capital len, you would say lower len. And that would basically goes over those, and then here you will pick only, here you should say, actually you would update n inside this because it's dependent on len. So you would say something like that. Instead of len, you would say len. And yeah, that's pretty much. Do we have n? Yeah, we do have. Actually, we don't need the n. Oh, yes, we need n is gonna be here. So yeah, I mean, you place it here, and then that's gonna be fine. But you can take care of that. I don't want to tell you what to do. But what I'm saying is, right now the len is set to the constant value, but you need to make it variable to solve the problem. Save this. Let's go forward. By the way, you see this fprintf with the standard error? If it's variables, so you need to have a variables flag and say, for example, if you have a variables flag set to 1, the variables is going to be, a external variable you define here. So for example, you say, I have an int variables. By default, we're going to be 0, but if it's 1, then I'm going to print this and make sure that you print it on the std out, not stderr, because if you don't print it on std, if you print on stderr, it's not going to show up on the autograder's result. So replace this with stder. Don't use stderr. Okay, let's see. How do we know which flag is initialized? As I said, for example, here you need to have, for example, int argc, just like the previous assignment, and then char star argv array. And then, for example, you can say, let's have a for loop for int I from 1. We have I here. No. So for I from 1, I less than argc, I plus plus, you can simply say, for example, here I have, let's say, variables, right? And let's say you have an int variable set to 0. The default value is always 0 because you don't want you don't want your program to be variables without a flag. Then you would say, for example, this is an example. Let's say if strcmp vi, comma, dash variable is equal to 0, that means I have a variable, so I will set the variables equal to 1, right? And then else, for example, if strcmp argvi comma dash n threads is equal to 0, then I would basically say let's have an int and threads initialize it to 1 because the default should be 1, and then here you say n threads equal to a to I of arg v plus plus I, because based on what the assignment says, the number of threads is specified after n threads. So the number of threads would be set to the next value, right? This is plus plus I. So you would do it this way, right? And then there are a bunch of other else ifs that you need to have. But basically, for every single flag, you have like 6 flags, and you have like 6 if else statements. And that's how it's how simple it is, right? It's not a big deal. It's just like go over all the arguments and see how to translate them, or how to make a sense out of it. Based on that, you can change the number of threads, you can change the number you can change whether or not it's variables, and so on and so forth. But again, I don't want to show you all the details. Okay. One more thing, the ID is basically a number bit from 0 all the way to whatever the number of threads minus 1. So if the end thread is 20, it's going to be between 0 and 19. If it's 90, it's going to be from 0 all the way to 89. That's the idea of it, a puzzle, a puzzle solver thread. And that's why you see this ID is cast to an integer, and it's gonna become the index of this buffer array. What is buffer array? Buffer array is an array of char stars. So it's gonna be a char double star, and basically it's like it's a 2D array. It's like a 2D ragged array of char stars, and each element of it is set to a very long buffer, which I'm going to show you later. Buffer size. Yeah, so let me go through the rest of the main. I'm a little confused myself. Okay, so we define a long start time, set it to get nano. That's the start time of the whole program. Then you have a thread number, you have a bunch of local variables. Size, for example, is buffer size over the number of threads. Buffer size, again, is that big number, because we assume the size of the program is, the size of the problem is very long. But it doesn't need to be that long. It can be, let's make it a little bit more manageable for the sake of this meeting. Let's make it 2 million. I'm scared of 2 billion. I'm looking at it, I just start crying. All right, so let's say it's 2 million. So the size is 2 million, and it's not reasonable. And basically, we're trying to solve a 2 million puzzle. That's a piece of cake. So the size of the puzzle is kind of determined. It's predetermined to be 2 million. And then you have a array of thread IDs. As I said, in the starter code, the thread size, the number of threads is set to 20, but you need to define it this way, whatever the user decides to have. But let's go with 20, and the buffer size is 2 million. So that's a reasonable values that we have here. And then I have a temporary arrays like this, temp and line, which I'll tell you what they are used for. Then I have a temporary pointer. I have a file star that is set to this. That's how you open a file in C. You just say F open, and R means I'm gonna read it only, right? And then I have a while fget_s, and I'm gonna use fget_s to read the file now, that we don't read the line. And then basically this is gonna read the whole dictionary. Remember, we had like a very long file with 93,512 lines. So this is gonna read all the lines, and it's going to store it in a temporary char array. And if the size is 0, it goes forward. It doesn't just skip that. And otherwise, if the size is not 0, so it's a legal string that has to be stored in the dictionary array. Dict is an array of 100,000 strings, and it's going to basically say dictionary of dictionary size, which is a counting how many words you have in the dictionary, equal to some space that we have to allocate for that a string that we saw in the dicta.txt file. And then we're going to copy the word in the dictionary into the array of dictionary at this index. And then we are going to plus the index to keep track of the total dictionary size. And then after we finish, we're going to close the file, and then we are done with the non-concurrent operation. From this time forward, we are going to create new threads and let each thread solve part of the puzzle. We're going to break the puzzle into smaller pieces, let each thread take care of that. How does it work? Let's say set the thread number to 0, thread number less than number of threads, let's say 20, thread number plus plus. We simply say buffer at thread number is malloc of size plus 1, where size is, as I said, it's going to be the buffer size divided by 20. In this case, it's going to be 2 million over 20, which is equal to 100,000. So that means if each of the 20 threads solve 100,000 piece of the puzzle, 100,000 times 20 is 2 million, and then they can all collectively solve the whole puzzle. And yeah, so basically by doing this for loop, we go over all the thread numbers, and then we create enough space in the heap for each buffer. And then we say, let's read from keyboard, which is going to be a standard input. You can redirect it to a file, which I'll show you how it works. And basically, we're going to read size plus 1 element. That size plus 1 basically means you're going to fill up this buffer. This buffer would be a size plus 1, so we're going to read this many bytes. And if you cannot read it, you just print some error and say, I cannot read the input. And after you read that piece of the puzzle that is designed for one thread, you basically create the thread using pthread create. And don't forget, when you're using this function, you need to have this pthread.h include. And also, when you're compiling the program, you need to use the -pthread flag. So in your make file, on the line where it asks you to write down the flags, don't forget, beside the other flags like -w or -g if you want, or whatever, or -i dot, for example. Don't forget to put -pthread. Otherwise, the make file doesn't work and you will lose like 10 points. So pthread create is going to create a new thread with whatever thread number is, and then word puzzle solver would be the function that I just showed you. It's going to solve a single puzzle. I showed you how it works. And then the thread number would be a number from 0 to 19 in this case, but your case it should be from 0 to the number of threads minus 1. And if something goes wrong, the pthread create doesn't work. It prints error. It says too many threads are created. Instead of nagging about it, I should have done it this way. I should have put it in a while loop. That's the right way to do it. I mean, it's fine if you nag about it, but it's better to try again, right? It's fine if you print an error that says too many threads are created, but you need to try again and make sure that this thread is created. So I'm going to put it in a while loop. And eventually I'm going to solve the part of the thread solve the part of the puzzle that is assigned to a thread with a single thread. So if pthread create fails to create a new thread, I will, with this while loop, I will say try again. So make sure that you set this to while, not an if. And then I have a for loop and say, let's go over all the threads that I have created and make sure that all the threads are joined. As you see here, thread ID plus thread number is the ith thread, and then you're going to join that thread at the end. And if you after you finish it, you print this thread has been joined. As I said, because you want the verbose flag to work, you need to make this std out, and you need to put this in a if statement and say only say it joined if it's variables. Otherwise, don't print this. But you will do this yourself. And at the end, again, if it's variables, you need to print the total time. The total time would be the get nanos, which is going to be a function showing what's the current time in nanosecond, minus the start time. The difference between finish time, which is the time at line 91, and the start time, which is the time at line 59, would be the total time of the program. And you can print this either in nanoseconds, or if you want to make it milliseconds, you can do that. You can simply say milliseconds, and then here you can say 0.2f, and then here you can say, let's divide this whole thing with 1.0 E6. Divide this by a million, that's going to give you the time in milliseconds. But again, I don't want to do that. I just told you you can do it if you want. So otherwise, it's going to be nanosecond. Nanosecond is going to give you a big number. For example, 1 second would be 1 billion nanoseconds. Nanosecond is 10 to the power of -9 seconds. So the numbers you get are going to be huge. That's why we store them in long integer. The start time is a long integer. But that's not going to be the same number that the assignment asks you to create. The assignment asks you to create a different long number with this name, total binary search time. Let me make this snake case. So you can define it this way, or let's go all the way up. Say, let's have a long this, make this total binary search time, and set this to 0, and also you need to create a mutex. Or when I say create, I mean declare a mutex externally here. You need to initialize the mutex here. The video that I have posted on Canvas shows how to initialize a mutex, how to declare a mutex. And I showed you in the class last time, if you remember, the bank account example. And you need to, this binary search happens here. So what you can do is, you can put this in a separate line, and you say int result equal to this, and then you search, and then you do results +1 here. Right before doing the binary search, you can simply say get nanos. That's going to be a long start. And then after you measure after you do the binary search, then you say lock the mutex here. Then you would do the binary search, total binary search time plus equal get nanos minus start. This get nanos is called twice, once before the binary search, once after the binary search. The difference would be the total time for the binary search. And then you just add this to the total binary search time, and then you need to unlock the mutex here. And this way you're protecting this variable from being corrupted. Remember the the bank account balance, which was corrupted when you have multiple threads. When you want to protect it, you just lock the mutex here, unlock it here. Where is the mutex? It's the one that is declared here, and it's the one that is initialized here. So for mutex, you need to declare it once, initialize it once, and then anytime you want to access this shared resource among all threads, you need to lock it beforehand, unlock it after. And that's pretty much what you're supposed to do for the total binary search time. And at the end, you need to print out the total binary search time as well. This is going to give you the total time, but not the total binary search time. That's a different story. That total binary search time has to be printed if you have this dash time flag. Okay. And, you know, in order to find out whether or not you have a dash time flag, you need to do it here. You see in this else, this is gonna continue. This else is gonna become longer to cover all 6 different flags / options. And that's pretty much it. Okay. So let me run this and figure out how things look like. Okay. And basically show you how running it would look like. Any questions so far? For the sorted and distinct part also, you can have something like this. You can create an array of char stars called solutions and protect it against data corruption using another mutex. Let me show you. Here, this mutex should be called, let's say, binary search mutex. But you need to declare another one. And that's for solution count. I'll tell you why you need to have another mutex with solution count. Of course, all the mutex variables should be initialized at the very beginning of the program. Don't forget that, otherwise the mutex don't work. And you can destroy them at the end of the main. That's another optional thing you can do. But why you need another mutex here? I'll tell you why. You need to define 2 external variables, an int called solution count that counts how many solutions you have. Of course, initially it's set to 0, but any puzzle solver who finds a new solution has to increase that count. And you must have a char star solution and set it equal to some max count. Set the size to max count. And this would be the set of all solutions. And max count should be defined as some constant, let's say, I don't know, 1,000. It's very hard to think that you have more than 1,000 solutions. So that's a good number. And then your solutions array will be an oversized array, but the real size is solution count. And whenever you solve a puzzle, let's say this result of binary search is not -1, and you just want to print it, right? Before printing it, first of all, you don't need to print it if it's sorted. So if it's not sorted, remember we had the sorted flag. If it's not sorted, you can print it, but if it is sorted, you're not supposed to print it. Why? Because if you print it, then you're not going to print everything in sorted fashion. You need to store them in an array of solutions. So if the sorted flag is raised, or even if the distinct flag is raised, you should not print it immediately, right? So I will say this. I will say if sorted or what's the other one? Distinct flags are raised, then you should not print it. Otherwise, then I don't care, you should print it because you find the solution, so you print it. But if it is not sorted, if it's neither sorted, if it's sorted or distinct, then you need to store it in the solution bank, or I call it solutions. Let's call it solution bank because that kind of make more sense. And this is how I do it. I will say solution bank with the solution count plus. It's supposed to become str duplicate of buff plus I. Now you may say, what is str_dup? That's gonna duplicate the string that is stored starting at buff plus I, and it's gonna give you a copy of the solution, and it's gonna store it in the heap, and it's gonna let this to point to it. But because the solution count can be corrupted because it's a mutual variable that is accessible by multiple puzzle solver threads, you must now lock the solution count mutex. And after you finish, you need to unlock the solution count mutex. The mutex you locked and unlocked here was the binary search mutex. So you have two different mutex, one for preserving the total binary search time against corruption. One is to protecting solution bank solution count against corruption. Do you understand? This is very interesting, and that's what you need to remember whenever you're dealing with say whenever you're dealing with multi-threading, you should always remember mutex should be used to preserve common resources against data corruption and race condition. Do not forget that these sorted and distinct are going to be two flags that you can define externally. Like here, you can say int sorted set to 0, or int distinct set to 0. And then you can raise them if you see the dash sorted or dash distinct. So I only have for variables. You can just extend that if else statement and make it work for the sorted and distinct. And then at the very end, after you join everything, before you end, you should say, you know, if you have sorted, then you have to sort the solution bank. Because solution bank is not sorted, you need to sort the solution bank and print it. And also, if you have distinct, you need to remove the duplicates from solution bank, right? If it's sorted, you should sort the solution bank. And also we can say if it's distinct, or sorted, you need to print the solution. So if it's distinct, remove the duplicates. If it's sorted, sort the solution bank. And if it's distinct or sorted, you need to print the solution. Solution bank is the one that we created here. Char star array. I was talking about this. It's an external variable. This is the bank that we fill out by doing this. We gradually, after you find the solution, you're gonna add it to the solution. You understand? I was talking about the solution bank. That solution bank is like an array that is going to keep track of all the solutions that different threads will find, right? You understand? If there's a dash sorted or dash distinct, you should not immediately print the solution because the user doesn't want it unsorted. The user wants it sorted. The user wants distinct solutions. They don't want duplicate solutions. So you need to be able to, you need to basically remove duplicates or sort the set of solutions before you printing them out. Make sense? Okay. All right. Let's run it. I'm going to stop sharing for a few seconds. I'm going to actually I already have it here, so I don't give me a second. Okay. All right, so let me share it again. All right. Should be able to see my terminal, right? This is basically Ocelot. And if I clear this and ls, I have a bunch of files. The starter code, which is called bank. I should have called it something else. Give me a second. Again. I'm gonna pause this again for a second. Okay, so as I was saying, let's list all the files. The word puzzle is the starter code that I have posted on Canvas. Random gen is a file, a program that looks like this. Let's beam it so you can see how it looks like. As you see, it basically says, give me an argument. That argument shows you how many letters or characters you want in this in the puzzle, and it just creates some random characters in the puzzle. So it's that simple. Let's compile with GCC the random gen.c dash o. I'm going to call it random gen, and then here ls. And then I will say random gen a million. Actually, we said 2 million, right? Yes. 1, 2, 3. And let's store this into 2 megabytes. txt. And for those of you who don't remember this notation, that's a redirecting of standard output into a file. Now, if I vim this, if I ls, I can see this 2mb.txt. That's going to be the what's that? The puzzle, right? Then also let me remove the bank. I don't need bank or bank. Let's see. All right, so this is how things look like. I have the puzzle itself, I have the dictionary, I have the word puzzle.c. And let me also show you the word puzzle and tell you how it's a little different. We gotta make a little change into it. As I said, I'm scared of 2 billion. So because of that, let's make it, let's make it 2 million. So yeah, let's keep it 2 million. I don't want to do too large of a number. 2 million is good enough. And you will do it with 2 million as well, please. Don't do it with 2 billion. That's too much. And I'm gonna send an announcement and I'm gonna ask everyone, please go with 2 million. 2 billion is crazy. And yeah, that's all about the changes I wanted to make. Of course, you need to update this with the things that I told you so far in this meeting. So let's WQ it. That means save it and close it. Then let's say GCC-O, word puzzle should be the name of the executable. So that's, remember I told you, you must use -pthread. That's what you need to have in your makefile, and then maybe -w to ignore warnings. And the C file that we have is going to be word puzzle. Let's see. That's going to compile things. And now it's time to run it. Just say word puzzle. And this program doesn't get any command and arguments yet because, you know, I don't have anything. But you will eventually gonna have lots of, like 6 different options and flags. But after you put all the flags, and after this, whatever you want to put, I don't care. I mean, I don't want to tell you what to put. You know, it's on the assignment. Then you need to say, get the input from 2mb.txt because I'm going to solve this puzzle. So I'm going to get the input from this file. That's a redirection of a standard input, and print the output for me on the console. This basically says nothing happens, and the total time is this much. It doesn't say it prints any, it doesn't find any solutions for the puzzle. The reason it doesn't find anything is because if I vim it again, what was the name of it? Word puzzle. The reason it doesn't find any solution is because 2 million is too few for puzzles of length 9. So I'm gonna make this puzzle shorter. So let's make the solution shorter, make it 4 only. And let's close this. Compile this again. Clear the whole terminal and now run it again with the same command. Let's see how this time things work. As you see, so many meaningful words can be found. Why this many are found? Because now you're looking for only now you're looking for the puzzles of length 4, so it finds so many meaningful words like low, like poor, and so on and so forth. And like open, ugly, vague, you know, all that. And then it's gonna tell you which thread finds which word. Like thread 19 here, yeah, thread 19 finds acre. Thread 2 finds Dale or something, and so on and so forth. If I do this, for example, let's do Vim again. And instead of 4, if I say 6, it should barely find anything, because the longer the puzzle is, the harder it is to find it. The harder the longer the meaningful word is, the harder it is to find it in a 1 million word puzzle. Let's compile it and then run it. As you see, it only finds this one. These are the solutions. Joe, yes. These are the solutions. Not too many. There's still too many. Wow. Yeah. Oh, yeah. So that's pretty much it.